by linear approximation, we are actually talking about the fact that we try to approximate certain values, let's say f of x, when x is very close to a certain point A. So let me draw the picture here. So please look at the graph that I draw here. We focus ourselves on certain point x equals a, and I draw the tangent line that's passed through this point on the curve y equals f of x. And let's say now, instead of calculating the values of f of x for x very close to a on the graph f of x, instead of that, sometimes we can do approximation if it gives us a much easier calculation. By linear approximation, we are talking the fact that instead of looking at the purple line, we actually look at the red line, which is a straight line, so it must be a linear function. And for the neighborhood of A, let's say if you take a very small neighborhood of the point A, and if you look at the point X that is inside this neighborhood of A, we expect that the values on this red line for the point X that is close to A is actually very close to the original graph, right? So please look at these two lines. They are almost the same. When X is very close to A, the values on the function f of x is very close to the values that you can get on the linear function that represent the red line, right? And the topic linear approximation is based on this concept, and I write down the formula here. So it is the linear approximation formula for the value function f of x, and the right hand side you see is actually a linear function, and it actually represents the red line, which is a straight line, and it is the linear function we talk about for this straight line. And the fact is that instead of calculating the value on the left hand side, which is f of x, if x is very close to a, so they are very close, then instead of going for the left side, we can actually compute the corresponding value for the right hand side. And x is so close to a, we expect that the left hand side value is very, very close to the right hand side value. So it is an approximation process. Let's look at the current example. So please look at the example I stated here. I'm asking you to approximate the value, which is the square root of 8.99, based on the linear approximation formula. And let me write down the formula first. So let's think about it. By using this approximation formula properly, please take a look at that. This square root of 8.99 is actually the same as f of 8.99. And of course, this is quite close to f of 9, right? So it looks like we can use a be 9. So it means that we can actually look at the formula on the right hand side as the formula where a is 9 actually. So let's look at this formula together. And now let's find the derivative f prime first. F prime is the same as 1 over 2 times square root of x, and which means that f prime of 9 is gonna be 1 over 2 times square root of 9. So f prime of 9 is actually 1 over 6, right? And let's put all the things back to the formula we have. And please note that f of 9 is just the square root of 9, which is 3. So it means that for the formula here, I use the purple star to represent that. It becomes 3 plus 1 over 6, open bracket, x minus 9, close bracket. And now, the actual x point we look at, actually 8.99, right? So it means that I can evaluate this linear function at the point 8.99. And let me write it down here. And this value is actually the same as a value very close to the number that I stated here. And that's actually the answer to this problem. And we're getting the value square roots of 8.99 based on the linear approximation formula.